So back with lesson 15, this time with number 21 through 40. And so let's get started with it. So what we've got is the table shows relationship between the monthly cell phone costs for plan A and the number of minutes used in a month. And then the equation shows the relationship between monthly cell phone cost for plan B and the number of minutes used in a month. So the table and the equation are each representing different cell phone plans. We're told that the flat rate is defined as the monthly cost for the phone when 0 minutes are used. So that's like the initial value. What is the difference in dollars between the flat rate for plan B and the flat rate for plan A? So we're looking at the initial value of both of these. And so the initial value in the table is right here. So the initial value for the green one is going to be 30. The initial value in the equation is going to be 35. And so the difference between 30 and 35 obviously is 5. And it's in dollars, so we should probably put a dollar sign. Difference in the flat rate is $5 between those two things. So we've got we've got an equation and we've got a graph for number 22. And again, if you need to pause and look at number 21 and make sense of it, that's totally cool. Number 22, we are asked to enter the difference in the initial values between that graph and that table. So the graph is going to have an initial value right there between 80 and 100. It's going to be 90. And in the equation, the initial value is going to be 45. And they're both positive, so it's pretty easy. The difference between 45 and 90 is 45. All right, I'll pause here and be ready to move on to 23. Okay, we're asked this time to do the rates of change. It's important to pay attention to the directions on these because that one says rate of change and this one says initial value. So be careful to be doing what you're asked to do on these. And so we are looking for rate of change in number 23. So Chris dropped a penny from the top of a 100-foot tall building. That's the initial value. That's where it started. Gravity causes the object to fall at a rate of 9.8 meters per second. And so if we were to write that equation, it would actually be falling as negative, so negative 9.8 meters per second, and it started at 100 feet. So you can see that our rate of change here is negative 9.8 because it's falling. On the equation, our rate of change is negative 1.2. And so the difference between them, again, a number line is helpful. So is a calculator. These are both going to be on the same side of 0. And so to figure out how far apart they are, I have to subtract because they're on the same side of 0. So 9.8 minus 1.2 is going to be 8.6. Okay. And so a simple way to think about these is if it's on the same side of 0, we subtract. If they're on the opposite side of 0, to get the distance between them, we need to add. And so 24, the outside temperature before a summer thunderstorm was 80 degrees Fahrenheit. During the storm, the temperature fell a rate of 4 degrees per hour. And so if we write an equation for that, we would end up with y equals the temperature's falling 4 degrees per hour, so negative 4x, and it started at 80 degrees, so plus 80. We're asked to do the initial value on this one, and so our initial value here is going to be 80. And on the equation, our initial value is 54. They're both positive, so that's pretty easy to figure out. We just need to subtract them. 80 minus 54 is 26. So again, I'll leave this up to your sub whether they want to continue playing the video. Stop the video at this point, but recognize that I am going to do a video of 25 through 40 and have that available to you. It will just be a continuation of this video. Okay, so 25. we're looking for the initial value on both 25 and 26. So I just want to check that before I get started, make sure I'm doing the right thing. And so a diver swimming in the ocean was exploring a second ship located at 250 feet below sea level. She has finished now and has begun to return to the surface at a rate of 3 feet per second. So an equation for that would look like y equals 3x, positive 3 because she's coming up from the bottom of the water, minus 250 because she was 250 feet below sea level. And so it's important to recognize in this case that that's a negative 250. And so the blue one, to get our initial value, we need to go down by 10 more to get to 0. And over on the right side, it looks like the pattern is that it's going down by 4 each time. So negative 28 minus 4 is negative 32. And so our initial value there is negative 32. So our two initial values are negative 250 for the green one and negative 32 for the blue one. So those are both on the same side of 0. So negative 250 and negative 32. All I need to do to get this is do 250 minus 32. And again, I'm subtracting because they're on the same side of 0. And that would give me 228. No, 218. So those are 218 units apart. 26. We've got, we're looking for the initial values again. So if we start with the table, here it's going down by 2. So I need to go down by 2 more. That puts me to 2. Down by 2 more puts me to 0. That's going to give me the initial value. And here if I go, it looks like I'm going up as I go that way, so up by 4. If I go up by 4 more, I get to negative 5. Up by 4 more gets me to negative 1. So my initial value for the green one is going to be negative 1. And my initial value for the blue one, this little statement we have here, the music store Rockin' Tunes has a $45 membership, then charges $5 per CD. So our rate of change is 5. Our initial value is 45. So it looks like y equals 5x plus 45. We're asked to do the difference in the initial values. And so we have a difference between negative 1 and positive 45. They are on opposite sides of 0. So I do need to add those values. And so the 1 here and 45 more is going to make 46. Okay, on to 27. Marvin and his friends wanted to go fishing on Clear Lake, so they rented a boat for the day. To rent the boat, they had to pay a daily rental charge of $30, plus a rate of $5 per each hour that they use the boat. So let's write an equation for that. It's going to be $5 for every hour, so that's our rate, times x plus a $30 rental charge, and so that's our initial value is the $30. We're supposed to find the difference in the rates of change of this one. So let's find the rate of change in our table here. This is, as we go down the table, going up by 6. And on the right side and on the left side, it is going up by 3. And so our rate of change, or our slope here, is 6 over 3, which is equivalent to 2. And so we need the difference between our rates of change, which again are 2 and 5. The difference between 2 and 5 is 3. So number 28, on Monday, Carly put $20 in her lunch account, and each day lunch costs her $1.50. So she started with 20 bucks in there, and it's going down by $1.50 each day because she's taking money out to pay for lunch. So the account looks like this: y equals negative $1.50, x plus 20. Again, because the initial value of the account is 20 bucks, and she's taking out $1.50 every day. and we're supposed to do the difference in the rate of change. So the rate of change for that one is negative 1.5. The blue one, our rate of change is positive 1/2. So if it's helpful to think about both of these as fractions, we can do that. So negative 1.5 is the same as negative 1 and 1/2. And then our other one is a positive 1/2. So if I go 1.5 and a half more altogether, that makes 2. So the difference in the rates of change for this is going to be 2. Alrighty. And moving on to 29. We're back to doing one with an initial value. So this is a little tougher. In this table, this is coming down by 3s. So it's not going to land on 0, which is going to be rough. And so hopefully you've done this before, where we use the y equals mx plus b equation to figure out what that initial value is going to be. And so here it looks like it's going up by 6. Over here it looks like it's going up by 3. So our slope is 6 over 3, or 2. And so we could say y equals mx plus b. Our rate of change is going to be 2. And I can pick any pair of numbers to put in for my x and my y. I will use 8 and 10. So my y value is going to be 10. My x value is going to be 8. That leaves me with the b to figure out. So I'm going to have 10 equals 16 plus b. And so solving it for b, we subtract 16, and we get negative 6 is equal to b. Excuse me. So our rate of change, initial value for that one is going to be negative 6. One moment. And, excuse me, our initial value for the blue one is going to be positive 4. So again, using our number line to help us figure out how far apart those are, we would have a negative 6 and a positive 4. So to go from negative 6 to 0 is 6. From 0 to 4 is 4 more. That's a total of 10. Okay, that one's a tough one because of the way that the table is. Let's go on to number 30. So we've got a table that looks like it's going to be easier. We are looking to compare the initial values. So this is going to go down by 2. Down by 2 again is going to put us at 2. Down by 2 again is going to put us at 0. It's nice that it lands on 0 this time. Here we're going up by 4 as we go down the table. So it's actually, it's going down by 4 as we go down the table. So it's going to be adding 4 as we go up the table. So plus 4 more is going to put us at negative 5. Plus 4 more is going to put us at negative 1. So our initial value for the table is negative 1. And the blue one for the graph is also negative 1. So the difference between those initial values is going to be 0 because negative 1 is the same as negative 1. Okay, and we are looking for the difference in initial values on the first one and difference in rate of change on the second one. So again, be careful with that. Let's see, initial value of this one in green is going to be at negative 5. And the blue one, initial value is going to be negative 4. So number line is always helpful for these like this. So we've got negative 4, negative 5. We can see that those are only 1 unit apart. So the difference in initial values there is just 1. On the one on the right, on number 32, our initial value for the green one is going to be 4. Oops, but it wants the rate of change. Liggle, be careful with that. So rate of change, we're going to be going from perfect corner to perfect corner. Looks like that works. So down 2 to the right 1, so negative 2 over 1, or negative 2. And then the rate of change of the blue one is going to be negative 3. So again, the difference between, or the distance between negative 3 and negative 2, they are both on the left side of 0. The distance between those is just 1. So another one with just 1 as the answer. I'll leave this here for a moment. We're on to number 34. 33, I mean. So a diver swimming in the ocean was exploring a sunken ship located 250 feet below the sea level. She is finished now and has begun returning to the surface at a rate of 3 feet per second. So we're going to need to write an equation for that one. We are going to be comparing the initial values of these. So we've got y is equal to, and she's coming up, so positive 3. X, she's starting 250 feet below sea level, so negative 250. So our initial value for that one is going to be negative 250. For the graph, we're going to do that one in blue. The initial value is 50. So we are comparing negative 250 and 50. So I'll do a quick number line sketch to help me with that. Those are on opposite sides of 0. So 50 is over there. Negative 250 is over there. And so we've got to go from negative 250 to 0. That's 250 units. And 50 more. 250 plus 50 makes 300 units apart for those initial values. So we have another one on the right where we've got a graph and a story. We're asked to compare the initial values. So for the graph, we'll do that one first. Its initial value is going to be 48, it looks like. And so I'll just kind of write that down over here. And then Mandy has a 150-gallon fish tank that she is emptying so she can clean it. She has a pump that is removing 5 gallons per minute. So in blue, we can say, okay, the amount in the tank is going down by 5 gallons every minute, so negative 5. And then it started with 150 gallons in it. So our initial value is 150. Our initial values are both positive. So they're both on the same side of 0. So the distance between them is going to be 150 minus 48 is going to be 102. Okay. Let's take a look at this one. We're trying to look for comparing initial values on that one, and then rate of change on 36. So initial value for our graph is going to be right there at negative 2. Initial value for our equation is going to be right there at negative 2. And so since they are both the same, they are both negative 2, the difference between them is going to be nothing or 0. So 36, a swimming pool containing 1,600 gallons of water is emptied at a rate of 300 gallons every 2 hours. And so this one's tricky because it's 300 every 2 hours. And so if we're talking about rate of change, we need to know how much for every 1 hour. So 300 divided by 2 is going to be 150 gallons per hour. So let's go ahead and write an equation for this one. It's being emptied at a rate of 150 per hour. So that 150 is going to be negative because it's coming out of the pool. And it's starting with 1,600 gallons in the pool. So again, it's important to recognize that when we talk about rate of change, we are not talking about how much for 2 hours or 3 hours or whatever. We're talking about 1 hour. and that's why this is 150 gallons per hour. So if we look at the other one, the equation here, we've got a rate of change of 25. So our two initial values are negative 150 and 25. So I do want a number line to help me with this one. So negative 150. It's going to be over there. 25 is on the other side. So I've got to go 150 units and then 25 more. So that's going to give us a total of 175 units between them. The difference between them is 175. Okay. Pardon me, everyone. I'm losing my voice a little bit. So I'll be on to 37 through 40, and that's going to be it for this video. So 37, what we've got is we are looking for the difference between the rate of change and also for 38. So I always want to be checking those just to make sure I'm doing the right thing. So rate of change here, we're increasing by 6 all the way down on the right side, and by 3 all the way down on the left side. So that rate of change is 6 over 3, or 2. The rate of change for the equation is right there. It's going to be negative 4. So we are comparing negative 4 and 2. They are on opposite sides of 0. So the distance between them is going to be those 4 plus 2 more. That's a difference of 6. On to 38. Rates of change, we got the green one on the graph here. Looks like we're able to go down 1 and to the right 1, 2, 3, 4. So that's going to be negative 1 over 4. Then the rate of change for the table, it's decreasing by 4 on the right side and increasing by 2 on the right side. So we've got negative 4 over 2. That rate of change is going to be negative 2. This one's a little bit tricky again. We've got a negative 2 and a negative 1/4. They are on the same side of 0. So we just need the distance between these two, which means we would subtract 1/4 from 2 in our calculator, and we would get 1 3/4 as our final answer. The distance between them is 1 3/4. Okay, number 39 and number 40, it's going to bring it home for us. That's the last of this fun that we are having today. So here we've got to compare initial values for both of these. So the initial value of this graph is going to be 20. The initial value of this equation is going to be 10. The difference between 20 and 10 is 10. Okay. And then the initial values on these ones as well. The initial value here is 25. And for the green one, and the initial value for the blue one is also 25. So the difference between 25 and 25 is 0. That's going to be it for this lesson and for this video and for this lesson, everyone. I hope that was helpful, and I hope you have an awesome day.